All right, buddy. Here we go. All that build up. And hey, everybody. Class recording has started. So, over the past couple of days, we have been looking at the relationships between velocity, acceleration, and displacement. So, how changes in one can cause changes in the other ones, right? If an object is accelerating, what does that mean about its velocity? And then ultimately, what does that mean about how far it goes? And if I remember correctly, no, I thought I had them written down. Anyway, we talked about a couple of equations that relate those different things, the velocity and the displacement based on the acceleration and the time and all those fun things. Okay? Yesterday, we talked about an object under the influence of gravity. And gravity causes an acceleration. So, two things about that acceleration. First, all objects will experience the same acceleration under the influence of gravity, as long as what? No other things acting on it, right? As long as gravity is the only thing affecting it, all objects will experience that same acceleration, okay? Sorry, the same acceleration as each other. What that acceleration is depends on our location. Here on Earth, that value is equal to 9.8 meters per second, right? The velocity of an object will change by 9.8 meters per second for every second that goes by here on Earth. If we go to the moon, the feather in this rock will experience the same acceleration as each other. It's different than the acceleration they experience here on Earth, but it's the same as each other. Good there? On the moon, it's about 1.6 meters per second. So significantly smaller than the acceleration here on Earth, right? If you look at the different, and Edie, that actually, as you know a little bit more about how we get that value, it's pretty easy to calculate, but it's directly related to the mass of the object. So, you know, if we round off the numbers, let's say we round off Earth's acceleration to 10 and round up Moon's acceleration to 2, okay? The Moon is about 1/5 the size of Earth, or something like that, right? The acceleration on Venus is very similar to the acceleration here on Earth, because Earth and Venus are approximately the same size. Mars is about half of what it is here, because Mars is about half that size. So it's directly related to the mass of the object that we're dealing with. All right, but here's what we want to get into today. Gravity accelerates all objects at the same rate. Here on Earth, that rate is 9.8 meters per second. But gravity doesn't only affect things as they're moving downward. Gravity also affects things when they're moving upward. And it causes the same acceleration. But, remember we talked about in the beginning of this unit, right? Acceleration can be three things, right? What can acceleration be? Changing direction, speeding up, slowing down, right? If we toss something into the air and it's moving upward, its velocity will have a positive value, right? It's moving upward, positive velocity. But which way is gravity pulling on it? Downward. So that acceleration is negative. If something has a positive velocity but a negative acceleration, what happens to it? Say again? Eventually, yes. What does it have to do before it stops, though? It has to slow down. So on the way up, the acceleration is positive because it's moving upward, but the velocity is positive because it's moving upward, but the acceleration is negative, so it will slow down until eventually it does what at the top? Stops up at the top, right? You're thinking forces. Wait till next chapter on that one. So, yeah. On the way back down, now the velocity is negative because it's moving downward. Gravity is still pulling it which way though? Downward. So if it has negative velocity, And negative acceleration, what physically happens to it? It speeds up if we have velocity and acceleration being the same sign. Okay? One last question, and this is a tough question before we get into doing some numbers. Up at the top, we've established what happens to the object that we throw into the air. Stops. Is it accelerating at the top? Okay, it is accelerating. It's doing what? It's changing directions, right? It's not currently moving, but it is changing directions. And also, remember, if we think about the very first day of this unit, 4 questions that we wanted to answer about an object, right? Does that sound familiar? One of them is, what will the object do next, right? That's acceleration. Up at the top, objects are currently stopped. Instantaneous velocity of 0. Right? If I use that term, is that cool? But what immediately starts happening after that? Starts gaining speed, but in the other direction, right? What happens next? It stops, but does it stay stopped? No. So an object can have a 0 velocity, but a non-zero acceleration. Does that make sense? Okay. That means it is currently stopped, but it will start moving immediately after. Okay? Can an object have a non-zero velocity and a 0 acceleration? It's got to be one of those two. Can an object have a non-zero velocity but a 0 acceleration? Talk to the person next to you. All right, so let's discuss.
Who said no?
So, 0 acceleration. 0 acceleration means what? No speeding. It's a constant velocity. No, it's not. Okay. Can something have a non-zero velocity? What does that mean? What is it? No. If it's a non-zero velocity, it is moving. Yeah? If it has a non-zero velocity, it's moving. If it has a 0 acceleration, what is it not doing?
Accelerating.
Not accelerating, right? Not changing. So something that has a non-zero velocity but a 0 acceleration is doing what? Constant velocity. Something moving in a straight line that isn't speeding up and isn't slowing down has non-zero velocity but 0 acceleration. Does that make sense?
Yeah, I heard 0. I didn't hear the demo.
What about that stapler? It does have a constant velocity of 0. So what is its velocity? 0. What is its acceleration? 0. That's 0 velocity and 0 acceleration. Does that make sense? Okay. Is that good? For that discussion was a little bit farther than I wanted to get into on that. Okay. Go ahead.
But if it's non-zero, that means that it's not going to that. So the answer yes or no?
The answer to the question I asked you, can something have a non-zero velocity and a 0 acceleration? Yes.
Okay.
Ready? Watch this. Okay. Ready? as it's going across the ramp, or as it's going across the ramp here, right? Does it have a non-zero velocity? Yes.
Yes.
Because it's moving.
It's slowing down though.
A little, yes. Right? Not enough really for you to tell though. So it is though, because there is some friction. So this is meant to not have a whole lot of friction. So in reality, it does have a non-zero acceleration, but that was. I didn't want you to get into that. So, right? So as we go here, right? It's moving, but it's not speeding up or slowing down until it gets to the books, right? When it gets to the books, now it has acceleration for the slow down. Okay? Is that good? All right. Let me introduce you to the coolest person you'll ever meet.
Joe Brown?
Aunt Minnie.
Yep, exactly.
Why is Aunt Minnie the coolest person you'll ever meet? Because Aunt Minnie gives you $10 per second.
That's a lot of money.
I know, that's what I'm saying, right? Coolest person ever, right?
It's $40.
Still, you have to sit there in front of Aunt Minnie for 4 seconds, and how much money do you make? $40. Hey, good job, everybody. We answered the first question.
Hassan said, why can't we just build a bridge to space?
It's actually kind of an idea.
Yeah.
The space elevator is actually
Space ramp.
a legitimate idea. So.
Like Willy Wonka in the elevator, how it goes up.
Well, people like it. It's like Mario.
All right, so to answer questions today, let's make an assumption because it'll make our lives a lot easier. Okay, we discussed that here on Earth, the gravity causes an acceleration of 9.8 meters per second, which is true. That number is a little bit hard to do math with.
Work with 10.
Okay, but it's really close to 10. So for our purposes today, why don't we just assume lowercase g, remember lowercase g stands for the acceleration of gravity, right? We're going to say that that's about 10 meters per second. It just makes math easier to do. Good there? All right, question number 2. It says a ball dropped from rest picks up speed at 10 meters per second. After it falls for 4 seconds, how fast is it going? 40 meters per second. Nope, because that's just a how fast. This is just asking us for a how fast, right? How fast is a velocity, or it's actually a speed, but okay. So we did that just by using logic and understanding what acceleration is, right? How do we define acceleration? Acceleration is a what? Change in velocity. If the acceleration is 10 meters per second, start from rest, so its velocity is what? 0. So in the first second, it goes from 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay? Remember, though, that earlier in this packet, we came up with an equation that summarizes that idea. Right? Does that equation look familiar, hopefully? Yes? If we substitute in information from this question, we should get the same answer. If it's dropped from rest, what's VI? 0. Here, what's causing the acceleration in question number 2? Well, what happens when we drop something? Why does it fall? Gravity, right? So gravity's causing the acceleration. When gravity here on Earth causes the acceleration, what is the acceleration value? 10 meters per second. Right? How far is this ball allowed to, or how long is this ball allowed to drop for? 4 seconds, right? We end up with that. Okay? Now, technically what I wrote on the board isn't correct.
Because you don't have
Right? This acceleration is a vector. It has direction. which way does gravity pull things? So what should this acceleration be? Negative 10, right? And that means that the final velocity would be what? Negative 40. Does that make sense? Good? All right, question number 3. I told you the coolest person in the world, Aunt Minnie, right? She's got a pretty cool husband.
He's not asking.
Uncle Harry. Now, well, that's a good, wait. That's actually a really good question. Okay? Is Uncle Harry as cool as Aunt Minnie according to this question?
I mean,
Well,
how
are you allowed to stand, or like, are you allowed to come back and get more money?
Well, let's just talk about, right? Why is Aunt Minnie cool? Because she's giving you money. How much money?
$10 per second.
$10 a second. How much money is Uncle Harry giving you? $10 per second. See, wait. The fact that you already have $20 doesn't change the fact that Uncle Harry is giving you $10 a second, right?
What if you have, what if you,
Well, he only gives it to you for 3 seconds, right? No, wait. There's a point here.
how do we know if you get to keep this money?
Wait, that question gets answered in a little bit, okay? That question gets answered in a little bit, okay? So, I hope you guys get this connection, because nobody ever took it this direction before, but it's a really good example.
I know.
Okay? So, is Uncle Harry giving you money at the same rate as Aunt Minnie?
Yes.
You're getting just as rich, just as fast from Aunt Minnie as from Uncle Harry, right?
Yeah.
Uncle Harry doesn't have as much time to give you as much money, but if you gave him the same amount of time, he would give you the same amount of money, right? Until right now, right? So, in this question, right, you started with $20. Uncle Harry was still giving you $10 a second, but only for 3 seconds. So overall, how much money do you end up with? $50. But if we think about it in terms of a change, right, you still changed by $30 over 3 seconds, regardless of the fact that you already started with 20. Yes? Okay, now, make this connection. No. Make this connection. A ball is thrown straight downward. So instead of just dropping the ball this time, it gets thrown downward. When it leaves your hand, it's already doing something, right? Its initial velocity is not 0. Okay? However, as soon as it leaves your hand, what starts affecting it? Gravity. And what does gravity do to things? Pulls them down. If we talk about it in terms of this discussion, right? It causes a what? It causes an acceleration of how much? 10 meters per second. Okay? It doesn't matter that the object was already traveling downward. Gravity will still cause it to speed up. Here, you threw this ball downward. It was already going 20 meters per second, but what does gravity now do? Makes it go faster. It adds another what? 10 meters per second for what? For every second. So in the first second, the ball was already traveling 20. Gravity will now make it go from 20 to what? 30. And in the second gravity will make it go from 30 to 40. And then in the third second, gravity will make it go from 40 to 50. just like before, it didn't matter that you already started with $20. Uncle Harry was still giving you $10 a second, just like Aunt Minnie was. It was changing by the same amount, regardless of what you started with. Same thing with gravity, right? Is that the final velocity? No, right? It's still going in the downward direction, so we should do this, okay? Now, it depends on the question, right? This question is just asking you for what? Right? That question is just asking you how fast, which is what? That's just speed, right? So technically, does that answer need a negative? No, because it just said how fast. Now,
Uncle Harry's the coolest person I've ever met.
you think?
Yeah.
You know who's the uncoolest person you've ever met?
Aunt Minnie.
No. So, hey, just you might not want to watch this at home, like with your parents after this next comment. All right. So, you know who's the uncoolest person you've ever met? So, question number 5, right? You have $50 and you pay Aunt Minnie $10 per second. Right?
You just lost $10.
No. What happened from question number 3 to question number 5? Who's the only person that would make you pay back the $10 that Aunt Minnie gave you? Your mom. Right? So, your mom, right? So somebody this morning said, wait a minute, isn't Aunt Minnie your mom's sister? Because she's your aunt, right?
Sure.
I always picture Aunt Minnie as being like your great aunt, like your mom's aunt, So question number 5 is when mom intervenes, right? Mom finds out that Aunt Minnie is giving you $10 per second. She's like, no.
Hey, she doesn't care about Uncle Harry.
Well, maybe that's just later on,
No, I
right?
know.
And by the way, I would just like say for the record, as a dad, your dad would never make you give back that money. He'd be like, whatever. So, he'd be like, Aunt Minnie's loss, I guess, So. All right, so in this case, hopefully this question isn't too hard, right? You have $50. You pay Aunt Minnie back $10 per second because your mom made you. When will your money run out? 5 seconds.
But would your mom make you pay extra money?
Or it was
Well, no. Well, you had $50 from Uncle Harry, so that was.
But she didn't.
That's true. Maybe she didn't know about that. So, well, see, you know what? Maybe you actually do come out $40 ahead on this, because maybe she just knew about the $50 that you had after Uncle Harry paid you, and she never knew about this original $40 up here that Aunt Minnie gave you originally, So, and Aunt Minnie's getting old. Maybe she doesn't remember she gave you that $40 to begin with. Maybe. I don't know. All right. So, number 6. So, I know you all have a lot of experience with this, shooting arrows directly into the air, right? You go home and take your bow and arrow, So. All right. What? Usually I just record one class. So.
And it's always this one.
Well, this week it's been always you, but it isn't always you, so I switch back and forth. So. All right. So you shoot an arrow straight up at 50 meters per second. When will it run out of speed? Five seconds. So let's talk about why, right? In this case, the initial velocity, it says you shoot an arrow upward, right? So it has a positive velocity. But gravity is acting on it which way? Negatively, right? So gravity causes an acceleration of 10 meters per second. If something is traveling downward, gravity causes it to go faster by 10 meters per second every second. But if something's going upward, it's going to cause it to go slower 10 meters per second every second. How do we know when it reaches the top? Stops, right? When the velocity becomes 0. So for this question number 6, right, if you start with 50, in the first second, gravity makes the arrow slow down from 50 to what? No, in the first second. 40. And then from 40 to 30. And then from 30 to 20, 20 to 10, 10 to 0. 5 seconds. Let's do that. Here, let's go here. Okay? But this question, so this question is asking us to solve for what? Well, when, right? It's asking you to solve for time. So we have to do a little bit of algebra, right? Does that make sense? How I arrange that, how I rearrange that equation? Is that good? So, the final velocity of this trip is equal to what? When is this trip of shooting the arrow into the air over? When it hits 0. Minus, what was the initial velocity of this trip? 50. Which way 50? No. Which way did we shoot it? Upwards, so positive 50. But what's the acceleration in this case?
10 meters per second.
10 meters per second, but which way is the 10 meters per second? Right, does that make sense? Because it's pulling downward. And so solving that, 0 minus 50 is what? Negative 50 divided by negative 10 is 5. Does that one have to come out positive?
Yes.
Yes, because we're solving for what? Time, right? Time's got to be positive. Okay. All right. So we already answered question number 7, right? What's the arrow's speed 5 seconds after we shoot it? 0 meters per second. Okay? But, even though it is stopped up at the top of this motion, is gravity still acting on it? Yes. So even though it is currently stopped at 5 seconds, it has an instantaneous velocity of 0. What will immediately start happening? Start coming down. Now, it's moving in the same direction that gravity is pulling it. So Bella, it will start doing what? Speeding up. What will its speed be after 6 seconds? If it's speed, what do we have to write? 10, right? If it's velocity, what is it? Negative 10. What will its speed be after 7 seconds? 20, right? What will its velocity be? Negative 20. If we want to go mathy on this, right? The initial arrow shots was this. Gravity, no matter whether we're going up or going down, always causes an acceleration of negative 10. If we look at that for 6 seconds, right? Positive 50 plus negative 60. It works. Okay? Good there. Okay? Now, the other thing we said was not just how fast something is going, but how far it goes. Right? where is the arrow that you shot up at 50 meters per second when it runs out of speed? Now, it would be 50 meters if it was going a constant velocity the whole time, right? Remember that we also had this expression. That expression we can use to figure out how far an accelerating object goes. This arrow that we shot up in the air, what was its initial velocity? Positive 50. When it runs out of speed, means the final velocity is what? 0. And we already established how long does that take? 5 seconds. 50 plus 0 is 50. Divided by 2 is 25. Times 5 is 125 meters. Does that make sense? Number 2. How high will the arrow be 7 seconds after it was shot up? Use this equation again. The initial velocity of this trip was what? Positive 50. It's important now. What is the velocity 7 seconds after we shot it? Negative 20.
Oh, do you mean the final answer? Is that what you're talking about?
How much time are we talking about here? 7 seconds. 50 plus negative 20 is what? 30. Divided by 2, 15 times 7.
Oh, it was so close.
Now,
Yeah, we got that.
hold on. Let's wrap this up here. What did we just solve for there?
Stop.
The displacement. Hold on, let me wrap it up here. Wrap it, no, not wrap it up. Wrap it up. All right. We solved for the displacement. What is the displacement? Distance from where?
Reference.
Distance from where we started. Here, we're 105 meters above where we started. That doesn't mean that's the whole trip, right? We went up and then came back down, but we're still 105 meters above where we started. Okay? There are a couple more questions on that sheet. And on the back of that packet, there are some good things to consider about doing these relationships. The one thing you really have to keep in mind is if we throw this object into the air, hey, psst. As we throw this object into the air, what does the velocity have to be up there? It's got to be 0. From there, you can figure out everything else. Okay? Good?